Multiplication.
Ooh.
Okay, so matrix multiplication. This is not commutative. So matrix A times matrix B, you can't flip that to be B times A. So don't do that. You may want to, but don't. The other thing is that your inside dimensions have to match, and then your new dimensions are the outside. Meaning this, I'll just write matrix A, we'll call it a 3 by 2. Okay, and that's going to be multiplied to matrix B. Now in matrix B, okay, its dimensions, in order for it to be able to be multiplied together, dimensions in matrix B have to be 2 by
3?
Anything.
Oh.
So I'll just put a different number in there so that you don't think 3 by 2 and 2 by 3. It could be 2 by 4. But these inner ones have to match, and then the outer ones are the new dimensions of your matrix. So the new dimensions would be a 3 by 4. Okay? So inside dimensions match, outer dimensions. So if we have a, let's go with a, we can do a 3 by 2 is fine. It's a little expensive. So 3 rows by 2 columns, 2, 0, 1, negative 4, 5, 7. Okay, and we're going to multiply that. It has to be multiplied to a 2 by 4. So 2 rows, 4 columns. So whatever, 3, 0, negative 1, 1, 5, 9, 4, and 2. Okay, so the reason why they have to match is the way the matrix multiplication works is when we go to multiply, you are going to take your rows and multiply it by your columns. There are 2 numbers in this case times 2 numbers, but you're only going to end up with 1 value. So when you do that, you take your 2 times 3 and then you add it to your negative 4 times 5, and that comes up with your new element. So row 1 times column 1 will give you, in your new matrix, it will give you row 1, column 1. So when you take row 1 times column 1, that will give you this value right here. That value is made up of 6 minus 20, so it'll end up being a negative 14. Where did I get the 6? You go 2 and 3, negative 4 and 5. Some people like taking the 2 and the negative 4 and writing it like this, and then the 3 and the 5 like that, and just, visually seeing it that way, and then you're adding those together. That would work. It's fine. I typically don't. You don't need to show 6 minus 20. You could just write negative 14, do the mental math, right? So in this case, if I want to find row 2, column 1, I would take row 2, column 1, and I take the first term and the first term, so 0 plus 25, and we would just get 25. And then if I want row 3, right, row 3, column 1, you're going to take 3 and 35, giving you 38. Then you go to your next one, row, because you're going to go row 1, column 2. So you're going to go 0 and negative 36. Then you're going to go 0 and 45. Then you're going to go 0 and 63. And you're always adding them together. Now you can add a negative. Exchange.
Very good.
Yeah. Like here, 6 plus a negative 20, you get a negative 14. Where I was adding the 2 numbers together. So then to get row 1, column 3, out here, you're going to go negative 2, minus 16, negative 18, 0, and 20. 20, negative 1, plus 28, 27.
Mm-hmm.
And then 2 minus 8, negative 6, 0 and 10, and 1 and 14 is 15. Okay? So,
Makes sense.
makes pretty good sense.
Hmm?
If you multiply a matrix by the zero matrix, what do you think you get back out?
0.
Zero matrix, yep. So if you multiply a 2 by 2 by a 0 2 by 2, you'll end up with a 0 2 by 2. Okay. Then you have the identity matrix. The identity matrix is a matrix like if you were to multiply 7 times 1, you get out 7, you get out itself, right? 16 times 1, you get out itself. So the identity matrix is the same thing, but it's not just the number 1, it's not 1s through the whole thing actually. It's 1s on the diagonal starting in the upper left. So the identity matrices are always square. So if you have an identity matrix, it'll either be a 2 by 2, 3 by 3, 4 by 4, and it'll look like this. 1s in the diagonal like this. So 1, 0, 0, 1, 0, 0, 0, 1. That's the identity matrix. And when you multiply something by the identity matrix, you get out the same matrix. Now, if you add something to the identity matrix, you get a new matrix. Mm-hmm. Because it's like adding 1. 7 plus 1 is no longer 7, it's 8, something different, right? So if you were to do this and multiply, let's just try 2, 4, 5, negative 8. Okay, and we're going to multiply, this is its own separate deal, we erase this. I was just saying, identity matrices are always square, 2 by 2, 3 by 3, 4 by 4. So if you were to multiply these together, again, you would take, we fully expect the answer, identity matrix times its matrix, we fully expect this to come back out, right? Mm-hmm. So here, let's just take row 1 times column 1, so you're going to go 1 times 2 is 2, 0 times 4 is 0, so you just end up with 2. And then you can get row 2, so 0 and 4, and then 5 and 0, and then 0 and negative 8. Okay, and you'll end up with the same thing. Yeah, Grayson.
Does the thing being multiplied to the identity thing have to also be square? For this to work?
Yeah, so what you're wondering is, if you had a 2 by 2, that has to be multiplied, right? A 2 by 2 has to be multiplied to a 2 by something. So let's go 2 by 3. Just mix it up. So 2 rows, 3 columns. So it'll look like this. Okay. We make up numbers 6, 4, 2, negative 1, 5, 7. Okay, so let's check it out. Your new matrix is going to be a 2 by 3. Innards match, so that's good. So 2 rows, 3 columns. What do you get? 6, 0, right? So you get out 6, 0, 4, what do you get out? 4. 2, 0, 2, 0, negative 1. 5, 0, 0, 7.
So if you had a 0 in the top left and went like 0, 1, 1, 0, then would it just switch the whole thing? Or would you get?
So if you did 0, 1, 1, 0.
Yeah, then would you get 5, negative 8, 2, 4?
So then this, would be 0 and 4, and 2 and 0, and then 0 and negative 8, and 5.
So it just flips it.
Yeah, it just flips it. Now, some of the challenges come when you have sometimes these are a little challenging when you have like 0, -3, 4, and 1, 0, -4. This one looks a little challenging because it's a 1 by, right? 1 by 3 and then a 3 by 1, so does it work?
Yes.
Yeah, it's a 1 by 3 times a 3 by 1, it works. What's your new dimension is going to be?
1 by
1 by 1, so it's going to have a singular element, right? So it's like, oh, things like there, it feels like there should be more to it, but there isn't. So you're just going to end up with one value, so it'll be 0, 0, and -16. Okay? So that one sometimes can prove challenging, or ones like it. Okay, if you were to square a matrix, let's say you have this matrix, you know, A is equal to 0, 1, 4, 7. Okay, that's your matrix. If I were to say, hey, square A squared, do you think you take a squared value and distribute it in?
No.
No. What are you going to have to do?
Just multiply by itself.
Multiply it by itself, yeah. So there's no like, oh, 0, 1, 16, 49. It'll just be multiplied by itself. 0, 1, 4, 7, like that. And so you would end up with 0 and 4, right? And then 0 and 28. And,
Wait, 28?
no, that's a 7. 4 and 0, 0, 7 and 4 is 28.
Oh, okay.
No? I think so. Am I wrong?
I don't know.
I feel good
I
about it.
don't think so. I think you're right.
I think it's right. So, squaring means you have to multiply it by itself. They use capital letter I for identity matrix, so you'll maybe see one of those in there. Excuse me. So let's pause there, maybe 21 minutes. Cool.
So getting back to the 1 by 3 and 3 by 1, if you switch those, you would get a 3 by 3, right?
If you switched it to be a 3 by 1 times a 1 by 3, then yeah, you would get a 3 by 3. Meaning 1, 0, -4, right?
Yeah.
Times 0, -3, 4. So this is a 3 by 1, this is a 1 by 3. So when you do that, now you're going to get a 3 by 3. Row 1, column 1.
So just basically multiplication.
Yeah, you're basically just going, in this case, it's a little more straightforward. 0, 0, 0, 0, 12, and -16. It's a little more straightforward because there's just one element to go to each one.
Yeah.
Versus these other ones, you gotta go to double elements. So, do you guys have a homework assignment sheet for this yet?
Yes, we do.
You do.
Okay.
You gave it to us yesterday.
Okay, very good.
Very good.
Very good. Very good. Get to work.
Very good. Get to